Hey team, it's Mr. Z, and today we're going to look at some key features of equations and basically how to draw some of the interview questions from No Graph. Let's take a closer look. All right, so essentially looking at this, it's a square root. When there's no radical given, I always know that it's going to be to the second. That is an assumption. And something we need to know about square roots is essentially that I can plug in the square root of 1 that will equal positive or negative 1, square root of 0. But the issue is the moment I put a negative in, it causes math to break. This is the same situation where if I had 0 in the denominator, math would break. So essentially, for my domain, what I know is that I cannot use negatives. Whatever the radical is, it has to be either 0 or positive, which is why it goes from 0 to infinity. It includes 0. If I put a negative number, it does not work, which is why it is not part of the domain. The range, however, when I look at the answers, notice that when I plug x in, when x is 1, that means y is going to be plus or minus 1. When x is 4, well, the square root of 4 is going to be 2 and negative 2. This means that my range is going to be both negatives and positive numbers. For my x-intercept, what I need to remember is to plug in the value y equals 0. So I'm going to let y equal 0 equals the square root of x. And in order to get x by itself, I need to square each side. That's going to be leading to 0 is equal to x. Thus, my point is going to be 0, 0. My y-intercept, to find it without a graph, is going to be similar. I have to let x equals 0. So this is a little different. Here, I'm going to say that what is my x value? 0. And it's going to equal the square root of 0. Well, f of 0 equals 0, meaning that when it's 0, the output, the y, is 0. So I answered the 4 basic interview questions: the domain, the range, my x-intercept is 0, 0, and in this case, my y-intercept is 0, 0. The rest of this is just going to be on repeat. This next guy, square root of x plus 1. So the idea is that with the square root, negative numbers are not going to work. What happens is it breaks math. So my domain is going to be, well, it starts with 0 to infinity. I can't include any negatives. My range, as before, is going to be negative infinity to positive infinity. The reason being is, for example, if I plug in x equals 4, that means g of 4 is going to equal to the square root of 4 plus 1. The output of 4 is going to be positive or negative 2 plus 1, meaning that the output of 4 is going to be both 3 or negative 1. Notice how my outputs can be positive and negative, which is why the range is the way. To keep on going, to find the x-intercept, what I need to do is I need to let y equal 0. So again, I plug in for my y value, 0. which is equal to the square root of x plus 1. Let's get that square root by itself. Minus 1, minus 1. I have negative 1, which is equal to the square root of x. I have to square both sides, which is going to turn into a positive 1, which is equal to x. Therefore, my x-intercept is going to be 1, 0. Let's find our y-intercept. For the y-intercept, to find it algebraically, I let x equal 0. This is going to be a minor difference. It's going to be g, well, x is 0 here, equals the square root of 0 plus 1. G is 0 equals 0 plus 1. Well, the output is 1, meaning 0, 1 is the y-intercept. So x-intercept to y-intercept, you plug in the opposite value for 0, and you solve. Domain and range. For even radicals, you can't have negatives. All right, the second half is, whoa, this is an odd degree. So before, when it was the square root of 2 of 4, that was plus or minus 2. Now the square root, or the cube root, of, let's say, negative 1 is negative 1. The square root of negative 1 does not exist. The cube root of 8 is going to be 2. Notice how with the odd root, there aren't two answers. What this is essentially saying is what number times itself 3 times equals x. So let's get back to the question at hand in the domain. Now, because it is an odd root, because it's odd, the domain is going to be negative infinity to infinity. My range, if I plug in negatives, I get negatives. If I plug in positives, I get positives. My x-intercept is going to be, well, let me let y equal 0. So I'm going to replace h of x with 0, which is equal to the cube root of x. In order to get rid of that radical, I have to raise both sides to the third power, making 0 equals to x. Therefore, my y-intercept is 0, 0. My y-intercept, I let x equal 0, and I'm going to do it again. I'm going to plug it in. H of 0 equals the cube root of 0. Well, this guy is going to be 0. Therefore, it's going to be 0, 0. In this case, it was the same. So, big takeaway is when it is an odd degree, the domain changes. Let's do one more. Okay, again, I see it's an odd. That means, remember, for an odd degree, the cube root of negative 1 is negative 1. The cube root of 1 is positive 1. Negatives and positives work. So, my domain, well, negatives and positives work. So that means I can plug all negatives, I could plug 0 in, I can plug in positives, and it'll be all good. Likewise, my range, it can be negative, or it could be positive. If I plug in a negative number, I get a negative. When I plug a positive number, I get a positive, meaning that the answers are both negative and positive. For my x-intercept, what I got to remember to do is let y equals 0. Therefore, I'm going to solve 0 equals the cube root of x over 2. How do I get rid of a denominator? Multiply the left side by 2, the right side by 2, cancel, and I'm going to be left with 0 equals the cube root of x. In order to get rid of the radical, I raise both sides to the same degree, and I get 0 equals x. Therefore, my x-intercept is going to be 0, 0. To do my y-intercept, I'm going to plug in x equals 0. So I'm going to go ahead and let x be 0. The cube root of 0 all over 2. I evaluate this guy. The cube root of 0 is 0 over 2. J is 0 is going to be 0, meaning it's going to just be the same point.